Hey guys, today we're going to look at Thevenin equivalent circuits. So Thevenin equivalent circuits are used to simplify a circuit with multiple resistors, current sources and voltage sources into a simplified circuit with one voltage source and one resistor for easier analysis and design. It's important to note that Thevenin theorem can only be used on any two-terminal DC network. So what we're going to do first is find a Thevenin resistance. So the first thing to do that is you've got to short circuit both the voltage source and the current source. And then we're just going to calculate Thevenin resistance, so that's the resistance between those two open points there on the right. So I've got the 4 ohm and the 12 ohm resistors in parallel to one another, and the equivalent of those two resistors is then added to the 1 ohm resistor, which you can see on the calculations there, and we end up with a Thevenin resistance of 4 ohms. So next we're going to calculate the Thevenin voltage, and to do this we're going to use nodal analysis. So the first node is up there in the middle, and we're going to call that Thevenin, because the potential difference between that node and the ground node is the same as the potential difference between those two open points there. So first of all, we've got 32, which is the voltage source there, minus VTH over 4, which is that 4 ohm resistor, plus 2, which is the current source going into the node. And then going out of the node, we've got VTH minus 0 over 12, which is that 12 ohm resistor in the middle there. Simplifying that down, we end up with VTH equals 30 volts. So what we've got to do now is draw up our Thevenin equivalent circuit. We've got the 30 volts that we calculated before and the 4 ohm resistor. It's important to note that there's no current source there because it's not needed, and it makes analysis of your circuit a lot easier.